Okay, so good afternoon once again. I'm going to share my screen, but today I don't have two screens, so we'll have to go forward with one screen only. Let me know if you can see the screen. So, are you able to see?
Yes, ma'am.
Yes,
Uh,
ma'am.
Yes,
the,
ma'am.
the the slides are in slideshow mode, right?
Yes.
Okay,
Yes.
okay, we'll
Yes,
wait.
ma'am.
All right. So, going forward with our discussion on, the evolution of computer science and computers, now we are slowly entering into the 1970s, wherein the home computers still did not exist, but was slowly getting the pace of it. And in our last lecture's discussion, we sort of ignited the discussion on the fact that, okay, everything was working fine. Computers were a part of industry and factories. What would have been a reason behind, uh, the idea that okay, there is a necessity for home computer. So some of the students had mentioned that it would have helped them in dealing with things that they were otherwise dealing manually. But what else, what other reasons do you feel uh, would have led to the development of home computer? That is first question. The second question that comes naturally is that since people had started thinking about home computers, that means there was a sizable reduction in the size of the computers that were getting manufactured over that period of time. So how do you think that in today's world, almost every house, I wouldn't say almost every house, but most of the houses in India may have computers today, mainly because of the education purposes of their children. But during that time, how do you think the people who were creators of home computer or computer which was suitable for home would have actually sold this idea, or would have reasoned the importance of computers in the life of people living during those times? Yes, go on.
Ma'am, they would have like their selling point would have been like convincing people that this was where the future was headed, and telling people that if you have a computer at home, you might be living in a futuristic lifestyle, and that could have motivated people to, in fact, go ahead and purchase home computers.
But is it really enough just to say that this is the future? I mean, can you elaborate a bit on it more? How would they have convinced people of the importance of this particular device inside their homes? So,
Ma'am, everything cannot be done in workplace, so few things can be done at home also, like different tasks.
so do you mean to say that people who were working in the offices were bringing their work to their homes to do on home computer? Is that what you imply?
Workplace mean big computers, like in a room full room.
Okay.
Nice.
Watson?
When the calculation function of the computer was itself like a magic for the people who didn't know how it worked. So basically, it also, I think it might have uh, attracted them. Moreover, the more features which were added in the computer, the companies might have just tried to make them realize the importance of the new features, and this might they might have been attracted by those features.
Okay. Thank you, Watson. Kalash, what do you have to say?
And the people were fascinated by the efficiency of the computer, so they might be thinking that what if we had at the home, and so the engineers were of the thought that what if we create some home computers so that we can have some good profit.
Okay, it is also important to remember that at this time, even people who are working in industries which were using computers, they might have some idea of the potential and the power of computers. But a lot of people would be oblivious to the fact that okay, computer can radically revolutionize their lives in such sectors. So people perhaps woke up to the power and potential of computers after seeing it, maybe in demonstration or in marketing firms, and that is where companies also spend sizable amount of money to market the home computers that they were manufacturing. Harsh, go ahead.
I think the home computers are used for only for geeks. They are used by a very small niche, as I seen in a show called Young Sheldon, set in 1990s. they brought a home computer, and they are not much used by them, only for very small purposes by the child. So as the home computer are used from schools, their further development, and more people are buying them.
Okay, okay, thank you. Harsh, Deep?
Ma'am, my personal thought is that computers was bought by people because of playing games. I thought that because that time was video game was just launched, and children are very fascinated about that how games are seeing, and rich people children buy that computer for their personal games.
Okay,
It's
so
my original thought, ma'am.
okay, that's a very interesting perspective, because in our next week's lecture we will also be seeing the chronology of multiple developments that have happened starting, I think, 1970s, and how different products have formed in the continuous years, showing the development of computers. Uh, Akhand.
Yes, ma'am. I think those home computers would have been useful, as people would have to store their data virtually. Large amount of data they would be able to store virtually instead of storing them on pen and paper.
But do you think they had this realization that they need to store data virtually? Do you think that they would be thinking like this during that time?
Ma'am, when these home computers were the engineers who invented these computers, I think they might be creating awareness among people regarding this fact that how these computers would be useful to store large amount of data, which would be otherwise bulky to store on pen, paper, or any other uh, non-virtual usage.
Okay, okay. Thank you, Akhand. Sai Krishna.
Now, maybe the companies would try to market the computers to rich people, so like someone mentioned. So, like maybe say personal communications and emails could be done between family members for rich people. And soon, once all the rich people start buying it, like common public already has a nice impression about what a personal computer is because all the rich people are buying it, so they want to get in on the action as well. So then, once an economically viable model becomes available, all the public will start to buy it.
Okay, so yes, perhaps launching it or marketing it by a reasonable causes as to why personal computers are potentially important in homes. They try to sell it to a few section of target segment, and then later on, when it spreads from word of mouth. Generally, when people use a product, there are two ways in which product's popularity gets spread. Sometimes it's about news and digital media, and other times it's about word of mouth. So people talk among each other, and they discuss. So perhaps that would have also triggered the conversations about the availability of home computers. Rathor, do you want to add something to that?
Yes, ma'am. I think not every company has a proper computer setup, but the employee who are work at that point, that place, if they are curiosity about the technology, so they are buying the new computer for new updating technology and know about more computers.
Okay. Yeah. So, all in all, people who are already working with the computers realize the immense impact it may have on the people's life for other purposes, and perhaps they sort of started thinking about the idea of home computers. People have mentioned in the chat also that maybe people wanted to know about after some years. Mahim mentions home computer in early 90s were brought by people who were fascinated about the new technology, and also I think they were not much useful because internet has had much growth. So all in all, this context is important, because till now we were talking about automating the computations which are happening at such a large scale in industries, factories, and you know there are so many other machines that are currently deployed in the industry and factories. We never talk about homifying them. But what was so special about the computers, that people thought that okay, these need to be in people's home for some use or other. So from there the discussion about the home computer started. And this is the this image is about the MIT's Alta 8800, which was the first commercially successful home computer. And shortly after, Apple launched a couple of prototypes for computers. Then Commodore and Tandy Radio Shack launched these computers. So of these computers, Apple II was by far the most successful. And seeing Apple's success, International Business Machines released the original IBM PC. So Microsoft also at that time negotiated a deal to provide OS to the IBMs and IBM compatible machines. So in 1977, around 1977, these three were the samples of home computers that were released. So as you can see, it is important to visualize, we are coming from where? ENIAC. And, all those computers which were vacuum tubes based, and to the home size, the computers that were literally of the size of the room, and then compacting them onto these devices. This has to be a feast of, sharpness of the human mind. How and obviously the developments in the electronic sectors, and we already talked about how microprocessor improved their processing due to the number of transistors that could be added, and the improvement of integrated chips as well. So these three computers were almost referred to as the 1977 Trinity by the Byte magazine during that time. But of these, Apple II actually was the most successful, and it went on to create multiple home computers. So these are some of the previous models of home computers that you can see on your screen. Any particular observation you have when you look at such images?
Ma'am, the computer looks like the size of the old TVs.
They look like old TVs, yeah. What else do you see? And
The keyboard is connected to
yeah,
monitor.
yes, keyboard is connected to monitor. And it's interesting that in when the earlier samples of home computers were built, keyboards were not really a part of it. But then it was realized that how do we input the data into the computer, and that's when the keyboard came into picture. This time they are attached to the overall device. You can see what else do you have to observe? Compare these computers with the computers that
Quite bulky.
quite bulky. So how do you?
Quite big in size.
Sorry.
Quite big in size.
Quite big in size, yeah. As compared to what?
And the screens are bulging outwards.
As compared to modern computers.
They don't have mouse.
The mouse is not yet there, okay. And someone said that the screen is bulging outwards. Anyone? Yeah.
Ma'am, the resolution also seems pretty poor compared to modern computers.
Yeah. What do you think about? Were they black and white, or they were colored, or any ideas about?
Ma'am, like
Ma'am,
top
black
right
and
one
white.
does seem to be like
Single
black and
color.
green, whereas the bottom right
Monocolored.
one does seem to have color.
Okay. Yeah. So
Monocolored.
these are some of the previous models of home computers, and but this is not just uh, the purpose behind which I'm showing you these images is so that now you see these set of home computers. You have seen the samples of computers that we discussed, which were quite huge in size, and now you're actually working on laptops. So see the transition of the technology that has happened. It is not isolated from how the human mind has actually, the extent of thinking and the depth of thinking the human mind has employed in continuously and consistently improving the experience of a user when it comes to computers. So around 1980s, this also saw the rise of personal computers, and Steve Wozniak and Steve Jobs. Because of these two people, there was a sudden development and evolution in the manufacturing of the home computers. And for those who are interested, I strongly recommend you to read I think it's the biography of Steve Jobs by Calder, Isaacson. Have you heard about that book? Anybody heard
Yes,
about that book?
I'm currently reading that book.
Okay, good. So it's pretty thick book, but in that Steve Jobs, the author describes how since a young age, Steve Jobs was interested in tinkering with things and experimenting, failing, and working with the electronics aspect of things. So it's a really nice read if you want to not particularly obviously to get to know about Steve Jobs, but also to understand that the journey that this person has taken to make Apple, as what it is. In 1981, obviously, then with computers, computer viruses were developed. In 1981, first truly successful portable computer was marketed. So the previous computers that we have shown, they were not quite portable, but with Osborne 1, there was a light in the tunnel of that, okay, whether computers can be portable. So our desktops that we had previously, when you purchase desktop, you keep it at home, so portability is really an issue. And laptops and palm tops have really eased the situation. So with Osborne 1, the portable computers were developed, and it was also during this time that in 1987, the US National Science Foundation, which is quite a famous foundation that also provides grants for researchers to conduct their research, started NSFNet, which was a precursor to today's internet. So I've added a link for the interested people to read about the history of internet. I will also add it to the classroom link. So these are some of the images that show Osborne 1 portable computer. This is the earlier model, and this was the redesigned case. So what are your observations when you look at this? What is it resembling?
Like laptops.
Okay.
Its screen is too small.
Typewriter.
Suitcase.
Ma'am, the
Suitcase.
screen to body ratio is quite small.
Yeah, so
Suitcase.
it looks like a suitcase. So, but the keyboard is pretty well formed, and because the monitor size has decreased considerably. So these were some of the challenges that they were facing during that time.
Uh,
And yeah,
Ma'am, are those inlets for like floppy disks or something?
I think so. I think so. I'm not sure, but I do think so that these are places wherein you can use the external storage devices. Yeah.
And ma'am, in the previous slide, for the first point, we used the word personal computers.
Hmm.
Are those the same as home computers? Like, can we use them interchangeably?
So home computers are personal, obviously, but personal computers, I think, also imply portability to them. That's what I feel. Home computers are homebound, so you cannot really move them as and when you want. But personal computers, PCs that we call of today, uh, they are. I think portability factor is attached to it. That's what I feel.
I understand, ma'am. Thank you.
Okay. So I think I have shown you this plot before also. So
Yes, ma'am.
if you see that with the rapid rise in the processor speed growth, uh, the size of the computers started becoming compact and more compact. Now, what do you think is the reason behind the high speed growth of the processors?
More demand for
Yes.
processors, I think.
Evolution of
But
transistors.
electronically, what would have actually led to the uh,
Increasing the number of transistor on
Foundation of transistor.
microprocessors.
increasing the number of, so I think someone is going to have a good lunch today. Okay, so yes, so increasing the number of transistors that could be embedded on a chip, that led to the, and this is only for 2000. So we have come 21 years after 2000, and if you look at, can you guess the number of transistors on Pentium 4 Intel or i7, let's say? Just briefly guess the number of transistors you think
More
Intel
than
i7
thousand.
core
More than
processor.
1,000.
A billion.
1000 what?
More than 1,000. I think.
1000 what?
Billion. A billion transistor.
A billion, okay. Around 2 billion transistors on that I core 7.
Ma'am, can we use Moore's law for this?
Moore's law, you are saying can we use?
Yeah, like if like as of 2000, if it is like
Yeah.
1,000 million, like 1 billion
Yes.
basically, can we basically like 2 billion in 2002, 4 billion in 2004, like that? Can we?
We can estimate. It doesn't provide us a absolute indicator, but it does show that okay, the number of chips increase after every 18 months. So as I have already shared 3 articles on Moore's law, so how many of you have actually opened them, if not read them?
I read them, ma'am.
Okay, so what did you find? Any fascinating thing that you find over there? It talks
Ma'am,
about.
the law was consistent for 30 years. That was the most fantastic thing.
Moore thought it wouldn't, like he was making an estimate for 10 years. He was doubtful for even like the 10 years, like from 1965 to 1975. But then he was astonished that it's like still holding up.
And who was Moore's, by the way? Which company was he associated with?
IBM founder.
Intel founder.
he was one of the founders of Intel company. Okay. So, so after 1990s and beyond, the computers revolution continues to go, and computers continue to become smaller and smaller. And with the birth of multiple technologies, we supercomputers have started now. Quantum computers are also coming into picture. So with this, I think we come to the end of our very brief discussion on personal computers and how computers themselves have taken a journey. Now when you operate on your computers, at least you have certain idea of where the computers are coming from. So today, if through this laptop I am able to communicate to you, you are able to communicate to me, we actually can perceive the extent of efforts and hard work that has gone into developing such kind of this. And I also want to show you a plot, and then I will ask you to interpret it. So can you see this? Can you see
Yes,
this?
ma'am. Yes.
Okay.
Yes, ma'am.
So this is a plot that mentions market share held by leading personal computer vendors worldwide from 2006 to 20. So have a look at this plot and tell me your observations. So which is the leading market company?
In starting, Lenovo is the leading company, but
Lenovo.
Lenovo.
it keep on decreasing.
At the beginning,
Lenovo and
it
HP.
is Dell,
Ma'am, like
so
the smaller companies are being
1%,
pushed out.
1% at a time, please. Yeah.
The smaller companies are being pushed out of the market as their market share is reducing.
So which are the small companies here? Do you mean Acer and
Yeah.
Acer?
Yes, sir.
But don't you think these are new companies? Relatively, they have recently come up.
MSI.
So you see, Lenovo has
Apple
been
and Dell.
closely followed by HP. But the important thing is that to remain relevant, even these companies consistently innovate the way they, uh, manufacture their laptops or PCs. So they consistently improve so that they stay relevant to the customers, and their sales never really dwindle. So this market share tells us about roughly about which are the leading companies. And as you can see that earlier these people and these companies were not really over there, but over the period of time, over the period of this transition, and because of the number of transistors that can fit in a microprocessor chip, the computer revolution has absolutely been radicalized. And another important thing is that try not to think electronics as separate from computer science. I think I myself am gaining a larger perspective on this, because the ability of computer to process the input and to do computations fast is considerably dependent on the quality of electronic material this goes into that case. So in current times, I think they are considered to be as quite separate field. But I think that as students who are learning computer science or electronics, you would come across as really strong professionals if you have good amount of knowledge of both, because especially electronics engineers who have hands-on coding experience, that would be really fascinating. And if software engineers or computer science professionals or students, if they know something about electronics and how things work, that would be fascinating, because later on when you are doing TensorFlow or AI or ML, sometimes what happens is that you're operating on a GPU, and you're trying to run a model, and then you have an error that RAM memory not sufficient, or the processor is not able to handle. So you have a bit of idea, okay, what may be going wrong, because when we create models at such a large scale, which are quite hardware intensive, especially when we talk about quantum computing. So it becomes easier and easier to relate those errors which may not be related to softwares. So try not to think of these two fields as very separate. In fact, they're quite interlinked to each other. So that is what I wanted to say. So now I will try to show you, with the help of one of my colleagues over here, the use of transistor as a switch. I would like to give you a background for this. A CPU chip, I'm not sure if I have an image. Okay, a CPU chip has a number of transistors attached to it. I want to show you one of the. Is my screen visible to you?
Yes, ma'am.
No, ma'am.
No, screen.
No, ma'am. No, ma'am.
No, ma'am.
No, ma'am.
No, ma'am.
I would like to show you a image that will give you a context of what I am talking about. So can you see this?
Yes, ma'am.
Yes, ma'am.
So what is this? It's a transistor, okay? These are integrated chip, IC, and this is the CPU. So because we are able to feed more and more transistor into ICs and then ICs into CPUs, and that is why the central processing unit's power has increased. Now, in previous lecture, I had asked you why computer operates on a binary system. Because it is because of the computer architecture. It just knows how to respond to zeros and ones, and transistors, it is actually transistors which can work as switch. So when you give it 0, the circuit will not be powered. When you give it 1, the circuit will be powered. So because the transistors quickly flip between on and off states, and how quickly they flip between, and the massive load that they are able to process, that depends on the number of transistors that go on to this particular central processing unit chip. So in today's class, in the later half, now I would like to demonstrate to you how transistor is used as a switch. I will also show you what transistor looks like and all these kind of things. So are you ready to see that?
Yes, ma'am.
Yes, ma'am.
Yes,
So,
ma'am.
so
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
give me 2 minutes. I'll call the person. We already have a setup ready. As you can see, those are the work benches behind me. So just give us 5 minutes as we get ready. Is that okay?
Okay, ma'am.
Yes, ma'am.
Sure, ma'am.
Yes, ma'am.
Yes, ma'am.
Stay,
Okay, ma'am.
stay there. Yeah, thank you. Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Invert.
Hello. Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good
Good
afternoon,
afternoon,
sir.
sir.
Good afternoon, sir.
Good afternoon,
लैब
sir.
दिख रही है? हाँ, यस। ये है हमारे इलेक्ट्रॉनिक्स की लैब। इसमें नंबर ऑफ फंक्शन है। ये अलग एक डिवाइस है, ये डिवाइस है। ये पावर सप्लाई है। ये पावर सप्लाई से हम जो कि हमारा जो रेगुलर होम पे जो इलेक्ट्रिसिटी आती है वो एसी रहती है। तो ये डीसी है, मतलब जो इलेक्ट्रॉनिक डिवाइस है वो डीसी में वर्क करते। ये है हमारे पास प्रोग्रामेबल डीसी पावर सप्लाई। तो हम एक सिंपल एक सर्किट बनाएंगे जो कि कंप्यूटर में वो ट्रांजिस्टर या स्विच कैसा वर्क करता है। ये है हमारा सर्किट। ये सर्किट है।
Are you able to see?
Ma'am,
Yes,
inverted.
sir.
Upside down,
It's
ma'am.
not clear.
No, ma'am. It's not
Blurred.
clear.
Resolution is very poor.
Upside down means
मैम एक और बार क्लॉकवाइज रोटेट करो ना फोन।
अभी ठीक है?
मैम ये
एक
एंटी
और
क्लॉकवाइज
बार?
है।
कॉपी से करना मैम।
नाउ?
एक और बार सेम जो जस्ट किया, एक और बार।
नाउ?
हाँ
okay,
मैम।
ma'am.
Okay, ma'am.
Yes, ma'am.
ओके।
तो ये हमारा ट्रांजिस्टर एज ए स्विच है। ये है हमारा ट्रांजिस्टर, एन पी एन ट्रांजिस्टर। इसका ये कलेक्टर है, ये बेस है और ये इमीटर है। वो जो भी ट्रांजिस्टर है ये ऐसा दिखता है।
So look at the transistor, guys. Can you see the transistor
Yes, ma'am.
Yes, ma'am.
यस मैम।
Yes, ma'am.
in my hand?
Yes, ma'am.
ये
Yeah.
ट्रांजिस्टर।
So you see the three
Yes, ma'am.
pins coming out.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
What is that?
Emitter
Ma'am,
बेस कलेक्टर,
collector, emitter, and
Yes,
base.
ma'am.
Emitter.
So
इमीटर बेस
these are the
कलेक्टर।
these are the small things that are fit into the IC, right, sir?
ये ब्रेडबोर्ड।
हाँ, मतलब integrated chip बनाने के
हाँ,
लिए. So this is actually the thing that creates the microprocessor. So millions and billions of this. This is what a transistor looks like. So now everyone knows what is a transistor.
That is a transistor you're
Yes,
holding.
ma'am.
Yes, it's a transistor.
Okay.
I will also share a manual with you on classroom to see. Okay. So this is a transistor. Now don't say you have never looked at a transistor. Okay.
Okay, ma'am.
Okay. Sir, carry.
आप डायरेक्टली ऐसे ये करो, मैं बोल
Okay.
दूं। ये है ट्रांजिस्टर। ये ट्रांजिस्टर का इमीटर, ये अंदर का बेस और ये कलेक्टर, ये पिन है। ये हमारे पास ये ब्रेड बोर्ड है। ये ब्रेड बोर्ड, इससे हम जो कि हमारे जो टेम्पररी कनेक्शन रहते हैं कि कोई भी सर्किट है, कोई प्रोजेक्ट बनाना है, तो हम यहाँ पे एक टेम्पररी कनेक्शन करते हैं। इसे बोलते हैं ब्रेड बोर्ड। मतलब ये ब्रेड बोर्ड इसलिए बोलते हैं कि ब्रेड साइज दिख रहा है, इसलिए इसका नाम ब्रेड बोर्ड। इसका जो भी इंटरनल स्ट्रक्चर है वो वर्टिकल, ये जो वर्टिकल लाइन रहती है इसकी, ये कनेक्टेड रहती है, हॉरिजॉन्टल डिसकनेक्टेड रहती है। तो ये हम जब प्रैक्टिकल ब्रेडबोर्ड का होगा तब। ओके, हम ये है रजिस्टर, ये रजिस्टर, ये रजिस्टर और ये एलईडी, एलईडी, ये एलईडी है, लाइट इमिटिंग डायोड।
So this is the LED, and this LED will be switching on and off depending on the transistor state. So transistor will be used as a switch to power off and power on this LED. Is the goal of the experiment clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Yes. Good.
तो ये हमारा सर्किट है, इस सर्किट के अकॉर्डिंगली हम ये कनेक्शन करेंगे। ये ब्रेडबोर्ड, यहाँ पे जो भी ट्रांजिस्टर है इसका इमीटर, बेस और कलेक्टर यहाँ पे प्लेस करेंगे। ओके, ये हमारा इमीटर है, ये हमारा बेस है और ये हमारा कलेक्टर। मतलब ये कलेक्टर की लाइन है, ये बेस की लाइन है और ये इमीटर की लाइन। तो यहाँ पे हम बेस और बेस की, यहाँ पे बेस में एक रजिस्टर यूज कर रहे हैं, तो यहाँ पे एक कनेक्शन करते हैं और ये बेस में एक रजिस्टर यूज करते
Let me show.
हैं। ओके, उसके बाद इमीटर के साइड में एक रजिस्टर है, उसके बाद में हमारा एलईडी है।
So this is a resistor and that's a transistor. We are creating this as per the circuit.
ये इमीटर, इमीटर का ये रजिस्टर यहाँ पे कनेक्शन। ओके, उसके बाद इसका जो ये डायोड है, मतलब ये एक डायोड है, ये इसका एक एनोड और कैथोड रहता है। ये जो यहाँ पे दो लाइन है, इसमें से एक बड़ा लाइन है और एक छोटा लाइन है। ये जो बड़ा लाइन रहता है वो पॉजिटिव रहता है, ये छोटा वाला नेगेटिव रहता है। तो हम ये पॉजिटिव एनोड यहाँ पे कनेक्ट करेंगे और ये कैथोड यहाँ पे कनेक्ट। अभी क्या करेंगे, जो हमारा पावर सप्लाई है कलेक्टर को VCC दे देंगे। तो यहाँ पे देखो, ये इसको ऑन करेंगे, ये इसका पॉजिटिव है, पॉजिटिव हम कलेक्टर को दे रहे हैं, तो ये है कलेक्टर। यहाँ पे इसे कनेक्शन करके ये पॉजिटिव यहाँ पे दे, और इसका जो निगेटिव है, ये निगेटिव हम कैथोड को दे देंगे। ये कैथोड को दे देंगे। ओके, और हमारा जो पावर सप्लाई है, हमें अभी इसको इनपुट देना है। जब हम इसको पॉजिटिव दे देंगे तो एलईडी ऑन होना चाहिए, जब हम इसको नेगेटिव देते हैं, मतलब 0 वोल्ट देते हैं, तो ये ऑफ होना चाहिए। तो हम क्या कर रहे हैं, इसका जो सेकंड सोर्स जो है हमारा, ये सेकंड सोर्स, इसका ये पॉजिटिव है और ये निगेटिव है। मैं निगेटिव को कनेक्ट करता हूँ कैथोड के साथ। कैथोड के साथ। और इसका जो पॉजिटिव है, पॉजिटिव हम बेस में लगाएंगे थ्रू रजिस्टर।
So this is the circuit. Now we will power it, right?
Power.
We will power it. See, if 5 volt power is given, if it's 5 volt, that means the signal is 1 and the LED should be powered. If there is no current, it is off, then the LED, that means transistor switch will be off, and as a result of which the LED will be switched off. So that we will be seeing shortly. Yeah. This is, I'm not sure if you can see it blinking. Can you see?
Ma'am.
Yes, ma'am. Little bit, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so this is signal 1. So
Signal
that 5 volt.
5 volt.
This is 5 volt is providing, and as a result of which the current is 1 in binary. So that is why the LED is powered. So it's switched on. Transistor is working as a switch. Is switched on. Transistor is switched on. So that is why the LED is on now. Now when we don't provide any power,
हम 0 यहाँ पे जो निगेटिव सप्लाई वो base पे।
so then we provide negative supply to the base, and it's basically
Positive
no
supply।
current is flowing, and so it's binary off. So the LED will not be switched on.
ये negative supply।
Sir is providing negative supply. Yeah. So he is providing it at the same point. Negative supply, there is no voltage, 0 signal, and that is why you can see the LED is in a off state only. Did you understand slightly, if not perfectly?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Do you want to see LED switch on once again?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes.
Not visible.
See,
Yes,
now you can see
yes,
it's
ma'am.
blinking. Yeah.
Yes, yes.
So this is how, so in a CPU, multiple transistors at the same time, flip-flop, and that is how they process the signal. So this is how transistors actually help in, understanding the state of the computer and helping it to process. So that is why the larger the number of transistors in CPU, what is the implication of larger number of transactions? What is the meaning of when there are
Faster processor.
faster? Yes, and that is why when you also go for
Also processing
purchasing
speed.
the computer, when you go to purchase computer, or on YouTube you see a lecture, they say buy i5, i7 or Intel core processors like that. So that is the reason. Now you understand the
Yes,
root
ma'am.
behind that. Yeah.
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
Thank
ma'am.
you.
Thank you,
We
sir.
had Arjun with us.
Thank you, sir.
He will also
Thank you,
take
sir.
electronic lab for you.
Thank you, sir.
Thank you, sir.
Thank you, ma'am.
Understood. Yeah. So how was it? Did you enjoy?
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
That was lovely.
Yes, ma'am. It is very interesting.
Can't hear you.
Ma'am,
Ma'am, your voice.
you're not audible.
You are mute, ma'am.
Sorry. Yeah. Now I think it's audible. Okay,
Yes,
so
yes, yes. Yes,
uh,
ma'am.
even though it was not very clear, but I hope I was able to uh, send a like more practical view of how transistors actually function. And this was only one transistor. Imagine it's such a, and it was I think NPN transistor that was used to for transistors as switch. So imagine now billions and billions of such transistors on your CPU, and they are working, you know, in a manner. So when a user provides some input, they do some processing, and then some output is there. So this was a very, very miniature view of actually what is happening inside the CPU. And that is why computers are able to operate in binary, because they can understand the signals in on and off stage. And transistors are a very significant part of the computer revolution. So through this demo, I just wanted to provide you, a taste in a virtual manner of uh, the how a transistor works and how it switches on and off between stage. And that is how, and in this particular case, it was used to trigger the LED. In other kinds of operations, multiple transistors are used to understand lots of other complicated calculations. So that was all for today's lecture. I hope you enjoyed watching the short demo that Arjun sir had provided. And next time when someone asks you, have you seen a transistor? So hopefully you would be able to reply in affirmative.
Yes, ma'am.
Yeah.
Yes, ma'am. Thank you.
Yes, ma'am.
Definitely.
Okay. So I think that's all for today's class. Think over what we have discussed, and in next week's class we will start off with understanding more about the hardware component of a computer. Okay, we'll see, we'll talk about lots of uh, internal components that make a computer, not really their functions, but just an overview of all the components, so that at least at a very basic level what hardwares combine together to form a computer. So we'll have a lot of discussion over that, and then slowly we'll move towards the binary system, conversion of numbers to binary and vice versa, and also decimal numbers. And slowly we'll go on to algorithms, pseudocode, and then take it from our journey into computer science in a much more focused manner. So is it okay? Is it clear now?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Also, let me know when you have any question that you want to understand in a practical manner, just like we saw it right now. So if you have any other things that you want to see, if any questions you want to you want to see how it happens actually, let me know. We'll try to conduct another demonstration for you to help you with that. Okay.
Turing machine, ma'am. Can
Turing machine, sir. Is it possible to demonstration of Turing machines? Turing machine, it takes a tape of million times zeros and ones, and it changes its stage depending on the input query the user.
Digitally.
I'll explain that to you. So, but Turing machine, I think, guys, it's more of a software thing. I'm thinking of giving an assignment on implementation of Turing machine via question, so I think that will be clear. But ultimately, Turing machine is actually, even though it's called as a machine because Alan Turing during that time actually created as a machine, but right now because of the computers and all, we can actually see it working through programming and coding. So I'm still thinking on actually giving you an assignment of Turing machine. So more clarity will emerge on it, I think, in another 4 or 5 days. Okay. But in this lecture, actually, I have a link which has details about how to create one machine. So I just want to show it to you right now. So I'll be sharing these complete slides today. So this is slide number 18. I'll just show you. So this is a page in which a person has actually created a Turing machine, and he has also listed the hardware components he has used, and the software components he has used. So actually anyone who is interested, they can actually create their own Turing machine. So that is the over Turing machine, but in the software form, I think I will provide you with some coding assignment to understand how it works. So interested students definitely can read it. If you want to implement it, then we can talk about it. Okay.
Okay, ma'am.
All right. So that is all from our side today. Thank you so much. Thank you, Arjun sir. Mm.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Good night,
Thank
sir.
you, ma'am. Project and
Thank you,
class.
ma'am.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Have a good
Thank you
night.
for demonstration, ma'am.
Thank you, ma'am.
Happy New Year.